Hello guys, hope you're doing well. We've already covered the theory of trigonometric integrals, so now it's time to practice. In this video and the upcoming ones, we'll solve a series of examples to help you gain confidence with this topic. I really recommend you follow along with each one carefully. Number 1. The integral of sine of x over 3 dx. As you know, the integral of sine of ax dx equals negative 1 over a cosine of ax plus c. So in this problem, a equals 1 over 3, right? So we have the integral of sine of 1 over 3 x dx equals negative 1 over 1 over 3 cosine of 1 over 3 x plus c. And finally answer equals negative 3 cosine of x over 3 plus c. Right? Number 2. The integral of cosine of the square root of 2x dx. As you know, the integral of cosine of ax dx equals 1 over a sine of ax plus c. So a equals the square root of 2. So we have the integral of cosine of the square root of 2x equals 1 over the square root of 2 sine of the square root of 2x plus c, or equals the square root of 2 over 2 sine of the square root of 2x plus c. Number 3. The integral of tangent x over 5 dx. As you know, the integral of tangent of ax dx equals negative 1 over a ln of the absolute value of cosine of ax plus c. So in this problem, a equals 1 over 5. So we have the integral of tangent of x over 5 dx equals negative 1 over 1 over 5 equals 5 ln of the absolute value of cosine of x over 5 plus c. The integral of tangent squared x over 3 dx. As you know, the integral of tangent squared of ax dx equals 1 over a tangent of ax minus x plus c. Right? So the integral of tangent squared x over 3 dx equals a equals 1 over 3. So 1 over 1 over 3 equals 3 tangent of x over 3 minus x plus c. And remember that it's very important. The integral of tangent squared of x dx equals a equals 1. So we have tangent of x minus x plus c. It's very important. The integral of cotangent squared x over 3 dx. As you know, the integral of cotangent squared of ax dx equals negative 1 over a cotangent ax minus x plus c, right? So we have a equals 1 over 3. So the integral of this expression equals negative 1 over 1 over 3 equals 3 cotangent x over 3 minus x plus c. The integral of secant squared x over 2. Again, as you know, the integral of secant squared ax dx equals 1 over a tangent of ax plus c, right? So in this problem, a equals 1/2. So we have the integral of secant squared x over 2 dx equals 1 over 1/2 equals 2 times tangent of x over 2 plus c. That's very, very easy and important. Or the integral of cosecant squared x over 4. Again, as you know, the integral of cosecant squared ax dx equals -1 over a cotangent of ax plus c. And in this problem, a equals 1 over 4. So we have -1 over 1 over 4 equals 4 cotangent of x over 4 plus c. The integral of 3 sine of 2x minus 5 cosine of 3x dx. Since we have a difference of two terms, we can integrate them separately. So we have the integral of 3 sine of 2x dx minus the integral of 5 cosine of 3x dx equals 3 the integral of sine of 2x dx minus 5 times the integral of cosine of 3x dx, right? So we have 3 times the integral of sine of 2x equals -1 over 2 cosine of 2x minus 5 times the integral of cosine of ax equals 1 over a sine of ax. So we have 1 over 3 sine of 3x plus c. And finally answer equals -3 over 2 cosine of 2x minus 5 over 3 sine of 3x plus c. The integral of tangent x minus 3 cotangent x whole squared dx. As you know, a minus b whole squared equals a squared -2ab plus b squared. So a equals tangent x and b equals 3 cotangent of x, right? So we have the integral of a squared means tangent squared of x -2ab minus 2 times tangent of x times 3 cotangent of x plus b squared plus 3 cotangent squared equals 9 cotangent squared x dx equals the integral of tangent squared x tangent x times cotangent x equals 1. So 2 times 3 equals -6 plus 9 cotangent squared x dx. And again, we can integrate them separately. So we have the integral of tangent squared x dx minus the integral of 6 dx plus the integral of 9 cotangent squared x dx, right? As you know, the integral of tangent squared x equals tangent x minus the integral of 6 dx equals 6x plus 9 times the integral of cotangent squared equals negative cotangent x minus x plus c. And finally answer equals tangent x minus negative x, negative 6x equals negative 7x, negative 9x equals negative 16x minus 9 cotangent of x, tangent of x plus c. The integral of dx over sine squared x times cosine squared x. As you know, 1 over sine squared x equals cosecant squared x, and 1 over cosine squared of x equals secant squared of x. So we have the integral of 1 over sine squared x equals cosecant squared x times 1 over cosine squared x equals secant squared x dx. And always remember, 1 over sine squared x equals cosecant squared x equals 1 plus cotangent squared x, and 1 over cosecant squared x equals secant squared x equals 1 plus tangent squared x. It's very, very important. So the integral of cosecant squared x equals 1 plus tangent squared x. So we have the integral of 1 plus tangent squared x times secant squared x equals 1 plus cotangent squared x dx. So we have the integral of, let's multiply these two expressions together. 1 times 1 plus cotangent squared x equals 1 plus cotangent squared x plus tangent squared times 1 plus cotangent squared x equals tangent squared x plus tangent squared x times cotangent squared x dx. And as you know, tangent x times cotangent x equals 1, because tangent x is the reciprocal of cotangent x, right? So tangent squared x times cotangent squared x equals 1, right? So we have 1 plus cotangent squared x. 1 plus cotangent squared of x equals cosecant squared x. So we have the integral of cosecant squared of x plus tangent squared of x plus 1. 1 plus tangent squared equals secant squared plus secant squared x dx. And as you know, the integral of cosecant squared x equals tangent x, and the integral of secant squared x equals negative cotangent x plus c. It's very, very important.